Alright, so in this video we are going to be starting off the whole process of understanding how to design abstractions. And to do that, what I'm going to do is review object-oriented programming with you, so go over how objects and classes work. If you're already pretty familiar with object-oriented programming, you might not need to watch this video. This video is just a little review. In the next basically 7 videos, we'll be talking about how to use object-oriented programming to design abstractions using data structures, to represent different ADTs. So let's start off with where you're coming from if you have never really thought too much about object-oriented programming. So I know that all of you know what a struct is now in C++, and a struct is a really good way to start thinking about how objects and classes work. What's interesting about object-oriented programming is that everyone who programs in this way has probably already used objects, right? Has already made objects and used them in their code. And so that's the good thing. And so now it's just a matter of learning how to write them, right? So structs are not objects, but they're a good place to start. They are a way to package multiple pieces of data into one place. So in this case, I'm making a bento box struct where I'm storing like different characteristics about the bento box, the role choice, the meat choice, the number of items, whether or not it's to go. And by packaging it together, you can kind of group items together that have the same characteristic instead of having a big list of all this data and having different vectors for role choice and meat choice and num items and to go for like all the different bento boxes that you're storing. This allows you to package them all together into one kind of struct type. And then when you want to access those, when you're setting up the struct instance, which is happening right here in the code. So I'm calling an instance of the bento box and I'm calling it Shannon Bento. And then you can fill in those members of the struct by using the dot operator. So Shannon Bento dot, and then any one of these variables that you set inside the struct will allow you to set up your bento box. This is great, but the idea is that, and we're using structs to motivate this idea, is what if you wanted to do more? Like, what if you wanted to, in addition to having all of these variables in characteristics grouped together in a struct, what if you also wanted to incorporate some methods that you could package with the data? So let's say, as a couple of examples, you wanted to use all of those characteristics of the bento box to calculate the cost of it, or count the calories, or check to see if there's, use a database to keep an inventory of all of the ingredients, and so check to make sure that, if this is ordered, that there's enough inventory. This is the idea. So turns out that we can do that. That is what object-oriented programming is. It's the ability to package up data and functions together, and it creates this concept called a class. And from the class, we're able to make instances of the class, which are objects. And so when you make an object based off of a class, it allows you to carry around not only the data itself, but also functions. And so that's all object-oriented programming is. And I don't know if you all remember when you first learned, when you first start programming, you learn how to do sequential programming. And you know that like everything reads from top to bottom, right? Left to right. And it's like, it's very satisfying because there's just this rule and it makes sense. And so if you define a variable below, if you define a variable on line 10, but you try to use it on line 5, it's not going to work, right? Then you add on to your programming this idea of branches, and then you're like, okay, well, it's not really sequential anymore because sometimes it goes here and sometimes it goes here. Then you add loops, and it's like, this is even worse because now it's going like this, right? And then you add functions, and then functions make your code go like all over the place, right? So now sometimes you're here, but then you go down here, and then you come back, and then, it's just like flipping the whole sense of programming on its head. I feel like when I learned functions, that's what I felt. I felt like, oh wow, like now I can do so much more. There's so much more power in my code. Well, object-oriented programming, if it's new to you, does that times 10, right? It like totally changes the way that you structure your code. It totally changes the way that you can think about like packaging different pieces of code together. And it's really, really powerful and really, really cool. So you have to have that sense before you kind of start building these abstractions. You have to have some sense of object-oriented programming because it does change things a bit. And it's confusing because when you're writing it, you're like in an object's member function, but maybe there's two instances of that object, one the object itself and one a different object that's been sent in. And it gets really confusing because you're like in like this world of like multiple like versions of your code running at the same time, if that makes sense. And so it takes some really careful and really thorough understanding. If you don't start from scratch on this and you don't make sure that you understand classes, the rest of this class is going to be really challenging. So make sure you understand this before you move on to building our abstractions. So the bento box class could look something like this, where you have the class declaration at the top here, and then you have its public and private member variables and member functions defined. So private member functions are listed down here. That was kind of everything that was in the struct. And then public member functions are the things that the user can access. One of the most important parts of the public member function is the constructor, and the constructor is what is able to kind of set the state of the class. And so here you can see that I'm calling the parameterized constructor, which is the second one. The first one is called a default constructor because it doesn't have any parameters sent in, and so the second one has all the parameters sent in. So the default constructor would have to set all of those member variables to some default value, like maybe an empty string, a 0, whatever that might be. And then we have all of our member functions here that are accessible by the user of the class. And remember that the class and the object analogy that's really nice to use is that the class is like the blueprint. It like provides all of the instructions and all of the plans, and the object itself is like an instance of that. And so it sets it takes the plans and it builds an object based off of it, just very much like having blueprints to a house and then making many versions of that house using the same blueprints. So here's the quick check-in. Given the bento box class that we've shown here, and it's pasted it in again, how can we change our role choice from spicy to salmon? So let's say it was initially set up as spicy in the constructor here, spicy tuna, and then what if we wanted to change that? So take a second to think about it. Okay, so here's one option here, which is you call the instance of the object and then you do the dot role choice just like you would with a struct. Sorry. Turns out this is not possible because the sorry. The role choice member variable is not public. It's a private member variable, so you don't have access to role choice, so you can't do this. So unlike a struct, you can actually in classes and objects, you can make different member variables private so that they're not accessible. I could also move that member variable into the public section, and then I could do that, but it's not currently. The next option is get role choice equals salmon. That's the next option there. You don't actually know what the get role choice function is. It's not defined here. It's only its function header. So you can see that it takes in no parameters and it returns a string. Based off of its name and its function header, you can assume that it gets the role choice, so it returns spicy tuna, but that it does not set it because it doesn't receive a parameter. So that one's also not going to work, but that is a public function, and if we had something like set role choice, maybe that would work. Same here, that doesn't receive anything, so it doesn't know about salmon, so that's not going to work. I'm really sorry. So the answer is that it's not possible for this particular version of the bento box class to set the role choice, and so if you wanted to do that, you would need to create something that's typically called a setter. So it's a really common way to write classes is that you keep all your member functions private, and then you create getters and setters in the public place of the class in order to get and set those variables. In this particular implementation of the bento box class, there's only one getter, which is to get the role choice. And yeah, so this is not possible for this given class. So this brings us to this idea of encapsulation, and you've probably heard this word before, but encapsulation is a way for you to control access to the class data. And so in this particular case, you can see that all of these private member variables, and we don't have any private member functions in this example, but you could, but we have 4 private member variables. They're all not accessible by the user. They aren't able to access them at all. And so the only way that the user can access those private member variables is through public functions. And so this is a really good visual that allows you to think about how encapsulation works, is that public functions reach over the wall of abstraction and grab what the user needs, but the user can't go across this wall. And it's, again, I know this is getting harped on quite a bit in this class, but this idea of abstraction is so powerful because it allows you to have really good control over what is accessible when you write code. And of course it's important for, like, if you're writing abstractions for other people to use, but it's also really powerful for yourself because it allows you to keep stuff contained, and if you are trying to touch something that you're not supposed to, it won't let you. And so it's kind of similar to like the idea of const, right? So putting that const there, even though you want to pass something by reference, putting the const there makes it so that you don't accidentally change something that you've passed by reference that you didn't want to, right? So it's just this ability to create these walls that keep your code doing what you wanted. So here are the elements of a class. And there's more, but these are kind of the big ones. So first you have member variables. This is what describes what the object is. So in the bento box class, it's like a package of different variables. We'll talk about for like abstractions that are used to, store a bunch of data. They're going to be those data structures that we talked about. The member variables will be linked lists or trees or C arrays or graphs, right? So it's the thing that's keeping track of the state of the object behind the scene. They're called a lot of things, and so the language of this is like might be overwhelming because there's so many different words for so many different things. But there's instance variables is a common word. I think that's a little bit more common in Java. Member variables, member data, fields, they're typically declared privately. That's the intention of the encapsulation. And every time you create an object from the class, the member variables have, there's their own member variables for each object, or they have their own fields. Member functions, is, all the behavior of the abstraction. It's all the behavior of the class. And they're known as methods instead of functions usually. And each object carries its own method, and the method can interact with all the data inside that object. So you don't need to pass in the member variables that are private into the member functions because they already have access to them, which you'll see in a second, or which you'll see in the next example in the next video. And then there's the constructor. The constructor is what is going to set the state of the new object. It oftentimes has parameters that allows those initial states to be set, but there's usually always, and there should be, a default constructor which takes no parameters, which declares what the object will look like if no parameters are sent in. Because that's used in all sorts of different things in C++ when you're kind of declaring stuff. Just like you're probably familiar with like default values in some of the other objects that you use. And you can have more than one constructor, and there's always more than one constructor. So when you create these classes, you're basically getting to design and create a new type. That's the best way to think about it. So just like with structs, it's like if there's something that doesn't exist within the standard types within the language, object-oriented programming and classes allow you to make those yourself. So creating a date class or a student class, those are all really common examples. And then when you create these types, the thing that's different is that from the struct is that you also are able to create all these operations on this data, which makes it really, really powerful. And so this includes getters and setters, as well as like any calculated values that you might want to include into the class. So that's it for object-oriented programming. This is, again, mostly a review. So if you're pretty familiar with object-oriented programming or pretty comfortable with it for whatever reason, this might not have been as useful. But if you've never seen it before, or it's really new to you, or you've had a very small interaction with it, hope this helped.